Okay, sorry about this last one. I caught it afterwards. Hopefully you got it. So let's start talking about a really fundamental concept in programming, which we're just going to lightly touch on just because I want you to understand, at least at a high level, what object-oriented programming is and how it differs from what we've been doing so far. Okay? So I've given you a link here to classes in JavaScript, and we're actually going to use one today. And then I think the challenge will be is to implement it into our code. That's what I'm thinking right now, but let's do this. So check that out. I think it's a good link. I was looking at it today. There is also there's some pre-concepts here about object-oriented programming. If you've taken other languages, they're often, especially if you've taken C++ or Java, those really, the only way you're programming is an object-oriented programming. So far we've been doing what's really called functional programming. And there are definitely some benefits. In a way, we've already been following some of the principles of object-oriented by encapsulating our code into these modules. So in a way, we've already kind of been doing it, but now we're going to more explicitly show you and talk about these concepts. So in here, in your main file, let's just do this, okay? I'm going to do const me, right, equals, right, and this is an object literal. So we've been using these object literals, right? So when we're pushing our code, right, we're pushing we're pushing our objects into our array, right? That empty array when we start, or if it's got data in it, we've been pushing this object that is just an object literal. When I talked about object literals, right, there's a couple things, and this is a good time to kind of think about this, right? So we have keys and values. Now this is not it, so don't write it yet, but keys and values, right? So whenever we think about how do we reference the object itself, it is like we have a key. So in this case, let's just write some keys and values. So name, right? Rio, you can use yourself, of course, right? Hair color, mine is reddish. And then we could say like location, right? I'd say like office. And then I could be like sleep score, right? So at least some numeric data, or there we go. Okay. So the other thing we can do though, and we kind of saw this a little bit, but we didn't really implement it, was we could have functions that are inside of an object, right? So we could say introduce, right? And in this case we could do function. Now, we'll talk about why we may or may not do an arrow function here. Intro, how about we spell introduce correctly? And then we could say console.log template strings, which by the way, from here on out, you should always use template strings unless you don't inject values into that, okay? This is, and then we'd go something like, right? Then, okay, this is, and then you go this dot name. We'll talk about this with, we could do this dot hair color is in, and we could do this dot location, right? Right now, something like that, right? So here we have our object, right? And so what do we know about this object? Let's actually go over here. I have my code running, right? Here's my object. And I could just, for now, set a breakpoint, refresh the page, and so what it stops. Now the reason I'm doing that is so I still have context, so I can do me, right? So I know that this is an object literal. I know how to reference all the items in here, right? We've been doing some of this already. Me.haircolor, right? Oh, helps when you do actually complete it tab. There we go, right? But the other thing we didn't really talk about was these functions, right? So this me dot, what was it, introduce, right? Right? So remember what this is, okay? So I ran it here, but let's actually go over here and run it, right? So when I call the function, in this case, it's a function inside of an object literal. It's a method, okay? So in here, right, when I say this, and actually it wouldn't be a bad idea to actually do this, console.log this at this point, okay? So when we're using the this inside of an object literal, or even inside of, and you'll hear a new term, a couple of them today, instantiated objects, right? It's inside, like it's context, this inside of here. And this is honestly why we're trying to move away from it, because it's hard to talk about it, because there's just so many times we refer to something like this and it gets confusing. But if you were to try to understand, no matter where you're at, if you're out on the global space, this would be your, what would be your global space? It would be, in this case, I'm going to step over that. I should have stepped over that. I'm not sure why it didn't. Oh, okay. So we'll just run over that. There it goes. And in this case, the this inside of me, right, is referring to its context. Now, we do talk about scope, and this is a little different than scope, but it's conceptually very similar. But now, if I console log out this in my global, right, I actually should have done window. Yeah, it should have done window. Must have been the way I'm running it. Hold on, let me find out. Yeah, it was a bad example, because when I let the code completely run and I type in just this like that, because when I was looking at it in here in main and doing it this way, it was still having the context for some reason, but really it's here what I was trying to explain is that it's the window object, which is the whole the whole window that we're looking at, right, is the larger context that we would think about for this. So when we call this inside of here, it's reaching inside of itself in its context to understand that. So that wasn't the best example. But really what I wanted to show you is this. Let's say we copy this and see this, how many times we say it. And we say you, okay, we do a new one, right? Student. Let's do Jane. I like Jane. Let's do Brown. Let's do home. Let's do she had a sleep score. She didn't sleep great last night. Okay. Now, a couple of things. Well, let's actually just look at it too. Okay. So let's u.introduce. So now we have another object. Okay. We have another object here. And this object, let's let this run, right? So we're just going to let this run. We'll jump right over it. Okay, so we know that works, and we know that works. And now we still have context, so we can at least look at it. The thing about these two objects, right, is, and this is one thing you can immediately start to notice, is the key value pairs, right, are not duplicated because they're unique for that particular person. Okay, when we create these objects, these are unique, but this part that is actually the functionality that we want is duplicated. It's like we're having to write it each time, and anytime you find yourself repeating yourself, that's when you should say, how can I do this better? And so in JavaScript and in any programming languages, we have better ways to do this stuff. And it's called the class syntax, okay? It's basically just syntax built on some functionality we already had in JavaScript called constructors. But it's based on, again, I'm not going to spend the whole time going over these concepts, just because if you were taking a strictly computer science class, you would want to have that experience, and those are good, and I think you need to have them. But for a beginning class, here's what we want you to understand, is that doing it this way is not only in, the chances of you making an error because you're sharing that functionality. We want to use a template, and that template is we're going to use a class to create these objects, and the objects that we create, we then say they're instantiated objects. And I'll go over that in a minute. Okay, so let's just for a minute get rid of this. Okay. Now let's come down here, and we're going to use a new, if you've never seen this. Now we're actually going to use new, so that's not the best. I'm going to say human. Okay? Right? So we're going to say human. And then we're going to do this. Now this is going to look different. You're going to be like, what? Right? New human. Or in this case, class called human, which will create a new human in a minute. And we'll call it a constructor. Okay? And that constructor is whatever the key values we were passing in, right? So what did we need for these? We needed name, we needed hair color, okay, we needed location, and we needed sleep score. Now, that's all we needed to create the object itself. Okay, so in this case, you say this dot name is going to be equal to name. This dot, and notice how you also don't have to use the commas between each one. It's just a different syntax, but it's doing something similar in this sense, equal to hair color. This dot location equal to location. Okay, that right? Yeah. This dot sleep score is equal to sleep score. Cool. Okay, so now we have a class called human. We have a constructor. That's your template. So whenever we create a new human, it's funny to say that, these are the things we need to know about this human that we're going to create. And a resulting human that we create is the instantiated object. Now, before we do it, let's actually also create the functionality that we want. Because we want to say, and this will look a little different, right? Introduce. But this part will be absolutely the same. So I can just come up here, grab that, right? Come back down here, and paste that in. Okay. So first, the syntax itself looks a little different, right? And it is, in some sense, obviously different than what we did up here. But it's much more efficient. And here's why. So if I say const rio equal, and this is new human, okay? And now what I want to do is pass that class, that template, what I want those values to be, right? And I would say red, office, and then I would say 95, right? But what I can also do here, rather than write it, I could just do Jane. Right? I say Jane. What did I said? Brown. She was at home. And she had a sleep score of 55. Okay. So now when we call new human, it's going to call the constructor. The constructor is going to instantiate the object, but each object instantiated has what we call a prototype that will then point back to here rather than to have it embedded in each object, therefore it's more efficient. So let me show you this, right? Dot intro, and then chain. Oh, dot intro, deuce. Okay, let's come back over here. Let this run. Okay, I think I had a break point already set, so we'll just let it run here. It's creating my object, okay, meaning me. So now we have a new object, and it looks like, if you were to just look at it, it kind of looks like when we did it up here. We could actually compare it, right? But in this case, it's prototype, even though it said it was, we saw that before, but now we have the constructor. It says, oh, okay, and we have introduce, which is setting on the class. The prototype is actually part of the structure now versus duplicating the code and in memory like we did above. So it's much more efficient. Okay, and there's much more, there's other benefits. Let me go back here. There's other benefits we get to using this type of structure, right? This type of different way of thinking about writing code, right? I was doing some research about this, and in client-side JavaScript, there's ways we can, and there's often things, because when we're creating new objects, right? You can think about this. This kind of is a preview for what I think we'll do for the code challenge this week. It's like, what part of our code are we creating individual objects? Think about that. And what part of our carbon footprint are we creating individual objects? Well, okay, right here, right? These are the objects that we're creating right here. But we're creating object literals. Could we use a class to do that and make our code even more efficient than it may already be, and more extendable than it may already be? So that's something just to think about. So the thing I want you to walk away with is that the way we've done things so far has been with object literals. Nothing wrong with that. Good time to understand and remind ourselves key value pairs, right? We still can have functions inside of objects are called methods, right? And we can then use this new syntactical sugar. If you've never heard that term, it's basically doing something similar, but it is also much more efficient in the sense of, instead of duplicating our functionality that we want for all of these objects that have the same functional need, or its data serves the same functional output, we can then write those functions once and have a prototype chain, right? This function is not setting on that instantiated object. It knows how to reference back to the chain to find it. What that means is really cool, is that, and I'll end with this, it's like if I wanted to update this, right? Like if I wanted to come up here, if I wanted to update this intro to change this, I'd have to do it each time. But in this case, if I wanted to do it with the class, right? And had sleep score of, right, this dot sleep score. So by doing that, right, I only have to write it once. I don't have to do it on each object, because the object that's been instantiated, that's been created by this process, has a prototype, and that prototype is where the functionality lives, so that it is encapsulated. It is, you know, it is better handled by both the system and by us as programmers, because it's much simpler. And we use this constructor, and we're still using the this concept. Okay, that's your introduction. Let's see, do I have a commit message for, yeah, Creating objects with class.